If I take a piece of cucumber and make a two slant cut, remove the pieces like this remaining cucumber is a very interesting 3D shape. If you look at it from here, it's a circle. If you look at it from here, it's a triangle. And if you look at it from another direction, it's a square. Now, if you observe this 3D shape, you will see a one U looking shape made by the interior of a cucumber. Question is, what is this U looking curve? One might get confused with this as a parabola. In 11th grade conic section, what we learn, take any cylinder and make a cross section at any angle and you would get always an ellipse shape. Here also, you are making a cross section of a cylinder only and the curve would be an ellipse. You are getting confused because this is a half of an ellipse. If I put the same ellipse on top of this, and you would see a complete curve, and this would provide a better visualization with an elliptical curve. Now the next question is, if I make a cross section to a cylinder, how do I believe this is an ellipse? That leads to understanding of what is an ellipse. If I take a nail and tie a thread around that, the curve formed by this would be a circle. All the points on the curve would have an equal distance with the center. Now if I separate these two center nail and create a curve with the same method, it would be an ellipse. All the points in an ellipse would have a constant distance with these 2 points. So ellipse is basically a circle only with just two different centers. That's it. So in the Kira's cross section, to prove that this is an ellipse, I need to find its two center, which is also called as a foci points. One interesting way to find the center of this ellipse is to insert a ball in the cylinder, one on the bottom and one on the top. So here you have a cross section and sphere on the top and the bottom has the same diameter as the cylinder. Wherever this ball touch the cross section plane is your center. Same thing we are trying to showcase using this visual model where these two spheres are touching the cross-section plane at a green point, which are the center of an ellipse. And all the points on the ellipse would have a constant distance with these two centers. If I lower the cross-section angle, you would see that both the center point, the foci point of an ellipse, are coming together. At one angle, they would coincident on top of each other. This is where the ellipse becomes the circle and the cross-section plane is parallel to the base of a cylinder. This is the same way we can find the centers of an ellipse in a conic section. You insert one sphere from the top, another from the bottom, and wherever they are touching will give you the center of an ellipse. And the dimension of the spheres are such that they are tangential to the surface of a cone. So we have seen an ellipse in our salad. The next question for you is, can you tell me what is this curve formed by the light and shadow by this lamp?